So just to give you some context, my name is Tushar. I've been working with Dream11 for more than 5 years. Dream11 is a sports tech startup based out of India. We have close to 130 million users, and we've recently been valued at $8 billion. That being said, ZIO HTTP is one of the first open source libraries that we've started working on. It's been a year, and we've been using it in production at a pretty good scale. So Dream11 actually, especially the edge engineering, has multiple pieces. One of those pieces is the push infrastructure, which sends messages to our clients. And we are talking about 5 to 6 million concurrent users getting messages in a sub-second latency. And all that is powered by ZIO HTTP, and it works flawlessly as of today. However, today I'm not here to talk about benchmarks and how it compares with other frameworks. I want to actually talk about the developer experience, the type safety that you get, and the compositionality, all that stuff instead. So this is going to be live coding, so hopefully everything works, and let's get started. So just to give more understanding of what ZIO HTTP is built on, the first and the most important domain is the HTTP domain. And it looks like this. And the idea over here is that it takes an input of type A, and HTTP encodes certain constraints. If the constraints are met by A, then you get a successful value of type B, or you can get a failure of type E. And that's the whole principle around which this works. You can, if you want to visualize it, you can think about it as something like this. Option E, comma B. Okay, so basically taking an input and returning a ZIO of option of E and B. So the ZIO is used to do any kind of side effects in this program. And in case the input A doesn't match the constraints, your program can fail with a ZIO of none. That being said, the most important and the better domain that most people work with is the HTTP app domain. And that kind of looks like this. RE, request to response. And this should give you a much better intuition of how what HTTP as a domain tries to solve. So basically what we are saying is there's a request that comes in, and if the request, and there's a route, if the request matches that route, you can get a response, or you can fail your program. Or if the route doesn't match, you essentially get a ZIO of none. And then you can compose multiple routes, and you can do a lot of interesting things. And we'll talk about that in a bit. So,
on the screen, it's a little small.
Is this better?
It's readable, but yeah, probably just a little bit. Yeah, that's great. That would be great.
Awesome. Cool. Cool. So, okay. So what we'll do is we'll create a simple HTTP app. The best way to do it is just say http.ok and just import the usuals. I'll just import everything from HTTP. We'll also need to import the server. So that's inside service. And here I can just say server.start, give a port, and OK. So, and let's see if the server starts. OK, this you need to return an exit code. Okay, the server started on port 8080. Now, if you make a curl request, you should get an OK200 response. Now, that's the easiest way, like 2 lines of code, you can create a simple HTTP server, which whatever request you make, it'll give you the same response. So if I say foo, it'll give you the same response. And that's what a simple HTTP OK app looks like. And what it's doing is it's taking in a request. If you try to visualize it using this domain, it's taking any request, and irrespective of the request, it always gives you a 200 response. Similarly, you can create an empty HTTP, which is http.empty. And you can deploy this. And now when you make a request, it basically means irrespective of what the input is, the output is going to be a ZIO of none. So if you make any request, and when there's no output available, by default, the server understands that it's a 404. That's the default behavior of the server. Now you make any request, it's going to give you a 404. And the type of this is an HTTP app. So we create an HTTP app, R and E are set to any and nothing because there's no environment requirement and it doesn't fail. Similar to this, you can make a little more usable app called greet. You can say http.text, you can say welcome. And let's deploy this. Now, the greet app, basically, irrespective of what the request is, will always return this welcome message. And okay, there you go. So, and in this, the application will intelligently also understand the headers. So it's setting the content type correctly. It's also setting the content length. And these are things that you don't have to worry about. So just with a few lines of code, you can have a simple greet app ready. One of the other very usual use cases are an app that fails. So you can say http.fail. It's equivalent to ZIO.fail. And you can say runtime. Runtime exception. Right? And if you see the type for fail, you can clearly see that this application, this HTTP application, fails with the runtime exception. And if you deploy this, fail, and try to make a curl request, there you go. It gives you this error. Now, the failure automatically is understood as a 500 exception. And if you want to look at it, actually, if you hit the browser, it'll look a little more readable, and that's what the server is trying to do. But if you are not satisfied with this exception, what you can also do is, you can use the or else, or you can say or else, or you can use the symbolic equivalent of or else, and you can now say http.text, something went wrong. So this way, what you're doing is you're taking an HTTP app which is failing and an HTTP app which is succeeding, and you're trying to see if you're trying to compose them together such that if one fails, the control moves to the one on the right. If you make this request, you get a 200 status code with something went wrong as text. And you can improve this by saying set status to status.internal server error. So, and you can actually improve a lot because there's a catch-all operator that is available and you can handle the exception in a lot better way. So now this is a little more, I mean, at least for curl, it makes a lot of sense by not throwing up an HTML response. Fail, okay, these are fine, but if you want to do something with, you want to create a slow app, the way you can do it is, you can say http.text, and put a delay, and you say 1 second, let's say 2 seconds. Now what will happen is, this is a simple HTTP app. If you deploy it, every request that it gets, it's going to wait for 2 seconds and then respond. So let's try to hit this. There you go, it's waiting. This is not the performance, this is not showcasing the performance of the server, it's actually a delay. Now what you can do is, one of the very interesting features are you can race this HTTP app with another HTTP app. And you can say http.text, I don't have time. Right? And now what we are doing is there's an HTTP app which just waits for 2 seconds, and there's another which just doesn't, and it just immediately responds. And when you hit this URL, it will respond with the 200. You can also set status to a status for timeout. I think there's a request timeout. So over here, again, I'm just setting the status so that it's not 200. And there you go, so you get a 408 status. you can put a timeout or a delay over here. So you can say dot delay, and you can say 500 millis. So now what's happening is we have an HTTP app which waits for 2 seconds or takes 2 seconds to respond. And there's another HTTP app which takes 500 milliseconds. And essentially, we are kind of timing out the first app by creating this separate app. And you can, when you make this request, unless the app responds in under 500 milliseconds, this is going to fail with the 408. Now let's try to just make it 100 millis. Try to hit this URL again. You can see the server logs at the bottom. There are no logs, but like you can see the server starting. So, and there you go. So now this is worth the wait. You get the 200 status code. Let's create another app where I want to do, so all these apps till now, they didn't care about the kind of request. So irrespective of the request, they would just respond with whatever the response was set. Now, if you want to create a HTTP where you have certain constraints on the request, basically you want to do some kind of intelligent routing, I have an app ready. So here what I'm doing is I have an app called flip, and I use the collect operator, and I say collect all the requests, and it takes a partial function. You say, okay, the method has to be get. If the request contains foo in the path, then you respond with bar. If there's a bar, respond with foo. If there's anything else, just reverse the text. Now this is an HTTP app which is defined on only a set of requests. So when you deploy this, the behavior is going to be a little different, because if I hit the same URL again, I'm going to get a 404 here. So I have to hit foo now to get a bar. I have to hit bar to get a foo. And if I hit other, again, this is going to fail because the route actually expects another parameter in the end. So you have to hit other with, say, functional Scala. When I hit this, the text is taken in and reversed and sent back. So now this is an HTTP app which has certain set of routes, and it's kind of working based, and it's basically piping the request into this collect method and seeing what pattern match actually matches that particular request and sends the response. This is a very genuine, most used use case. The other ones are, mostly for demo, I guess. So you have this flip. Now what you can also do is, if you want to create an app which takes in a request, I want to echo the response. So I want to echo the body that is being sent. So what I can do is, I can create an app like this. Now here what I'm doing is I'm using the collect M operator, which means that instead of taking a request and returning a response, I'm taking in a request and returning a ZIO of response. And that's required because when I have this request, a request has a get body as string method, which returns a task of string. And I take that string which was being sent in the request, and I want to send it back as a response over here. So that's what is happening over here. Now, if I take this echo app and deploy it, and let's try to echo. And I want to do a post. I want to send this string. When I make this request, and that's what I get. So this is a post request, a curl using curl, and when I'm making this request, I'm getting the response. In the response, I'm getting the same data. I'm going to try again with something else. That's all this is doing. Now, this is the way you can create various kinds of HTTP apps. Right? One of the things that you can also do is you can combine them. So you can say val, and you can combine them like this. Now, the combination of apps can be done using the ++ operator. So this has changed. It was using triple plus. Now it's using just 2 pluses. Now the idea over here is, if there's a request that comes in, and if the first app, the app which is on the left, if the constraints are matched, then the response is produced and sent back. If the constraints are not matched, the control is sent to the app on the right. So in this case, the request first comes to the OK app, and if there's a value, if the response can be produced, the combined app overall returns that particular response. If the response is not available, then the control will go to empty. Similarly, from empty, it will go to greet and error and slow and flip and everything. So now if you, let's call this as error. So now if you hit this URL, so I'm hitting this, the base URL. Okay, I need to deploy combined. Okay. I hit this URL, you get OK. Now what if I hit foo? You still get OK because OK is defined for any kind of request. So the control never moves to the right. Now that is also true for empty. So if I remove OK and I put empty and I make a request, for every request I'm going to get, oh, not really, because for in this case, when I make a request, empty is going to give me an empty response and the control goes to greet. So whatever request I make, it will just respond to via the greet app. So it doesn't matter what the URL is. And you'll always get the greet because empty basically doesn't produce any response. So now these apps, I think the flip and echo are the two apps that can really make sense here. So now if I make a request here and I say foo, I get a bar. If I make bar, I get foo. And if I say other and say function Scala, I will get the reverse text. I can also use echo. And now echo was a different app and flip was a different app. Now I can, because I've combined them, both of them work. So echo also works. But if you think about it, this combination might not be sufficient for some of the use cases. Sometimes what you want to do is you want to route requests more intelligently. And the way you can do it is essentially create a separate HTTP app where you get routes, pattern match on it, and then move and shift the control to these specific HTTP apps. The way it can look kind of like this. It's very simple. So what I'm saying is, I'm saying http.collect requests, so all the requests that I get, I pattern match on them. I don't care about the method. Now if the request looks like /OK, I want to execute the OK app, and if it's empty, the empty app, and so on and so forth. Now this, if you see let's try to actually run this app. Let's try to deploy and see if this works. Not really, because what we are doing here is we're creating an HTTP app that takes in a request but returns an HTTP. So if you see the type for intelligent, you can clearly see that it's taking a request but returning an HTTP. Can we do better? Can we fix this? You can. You can just call the flatten operator on it. And now the output is properly inferred. You get the environment clock because we had that delay, that slow app, and a throwable because get body as string was failing with a throwable error. And now this is an HTTP app that can be deployed, and it's actually working. And if you make this request, curl, let's try to hit the normal request. You get a 404 because that's not there's no route that is defined at root level. And if you want to hit the OK app, you hit it like this, so you get an OK over here. And if you hit empty, you get empty, so this is also working. If I hit greet, I get welcome. If I hit error, I get a 500 error. If I hit echo, and this, I'm getting the echo is also working. Let's see, slow works. Okay, slow is working because the delay is smaller than the timeout. Let's try a flip. Does this work? It's a very interesting use case because what is the URL that I need to hit? So let's say I hit flip foo. That won't work because if you see, The flip app, at least over here, expects the URL to look like /foo, whereas the intelligent app expects the URL to look like /flip. So how do we make sure that this particular app called flip is mounted correctly over here? So one of the ways you can do this is you can use the write associative operator, and you can do this, and you can get the path over here. Now this path is everything apart from flip. So from the URL that you hit, the request that you make, and from the URL, it will remove the flip from the beginning, and everything else that is remaining is available to you as path. Now this flip app, what you want to do is the request, it's still getting the same request. The request will still have whatever URL you have. So you want to now modify the request that is being sent to flip. And you can do that by just calling contramap and request and underscore. This is the request. So you get the request, access to the request that this app is going to get. And you can say set path. I can do this. What we are doing here is, it's fairly straightforward, but very interesting, because what we can do in this kind of scenarios is we can map and contramap and perform any kind of transformations on these HTTP apps. So this way, a request that we make which starts with flip actually will work with this flip app. So let's try it. Let's try to hit with foo, and you get a bar. This worked. If you hit bar, you get foo. And this works at any level of nesting. So you can now hit other, and you can hit like this, and there you go. So, and very straightforward stuff where you are able to mix different kind of operators to solve these kind of use cases. And I'm not sure if anybody else uses these kind of capabilities in frameworks, other frameworks. You can simplify this. You can also say flip.set path. You can say .set path and path. Just there's a helper method available, and it will do the same thing for you. So the URL, and this should work. Okay, so what if I want to add some custom headers to this intelligent app? Let's say I want to add a date header. So what I can do is I can create a method def get server time. So now I've written this code. You don't need to understand what's happening over here, but this is some line of code that you'll have to write. And in essence, what it returns is a ZIO of, clock fails with a date exception and a string. So the string is the value that I want to send in the header. Now what I'll do is I'll just say .map m. So that means any output that is coming out of this intelligent app, which is basically a response, I want to _.set or add header, and I can do this. So response, I want to say get server time .map time. Take the time, and I say response.add header date time. Okay. So now what's going to happen is every time there's a request that comes in, whenever the response is available, a new header called date is added. Now let's see if this works. You can see the date is added. Now the value also changes, so it's working. Let's try some other route. Let's try OK. It works. Let's try empty. In empty, it doesn't work. And that's very interesting. So that's because the operator map only applies when the response is available. So if the response isn't available, this operator doesn't work. What you need to do is you need to handle a little more edge cases to make all of this, to add this particular header and the response. A more easier way to do it would be, instead of doing this, you can say map _dot with server time. Now with server time is very interesting. it's significantly more performant. The earlier implementation would calculate time every time you make a request. So if you got millions of requests in a second, it'll try to calculate the time millions of times. And if you see, the precision actually is up to a second. Now with server time is a special operator that we've added for performance. And there's a lot of such specialized operators. With server time will calculate time once a second. So you don't allocate a lot of memory and caches and does a very good job in terms of performance. Hopefully this doesn't work. This works. So now you'll see that the behavior is the same. The only difference I think is that it's using the lowercase. That being said, it's significantly more performant. There are other operators for performance like memoize that you can check out. There's nothing to demo in memoize, but the idea of memoize is that if there's a response, because you're working with immutable data structures, when you have to write it on the channel, when you have to send it over the network, you have to eventually convert it to bytes. With memoize operator, anything that can be converted to bytes, it will start caching it. So you want to be careful how you use it, but once you start using it, the memoization will happen only once. The caching of that conversion to bytes will happen only once, and it'll get cached, and you'll get significantly better performance. This makes sense only for values where the response doesn't change that much. For everything else, it can cause memory issues. So now one of the new things that we've sort of added to this, you don't need this, I'll just keep it. So one of the new things that we've added to HTTP and ZIO HTTP is the middleware API. And the way you can use it is, you can just import it. You can say ZIO HTTP dot. Okay, it works exactly like how test aspects work, and that's the main inspiration in terms of syntax. Now, this slow app that we had, there you go. It was waiting for 100 milliseconds, and and it had a lot of code over here where I was trying to race it with some other app. What I can do is I can comment this out and take the slow app and use the time out middleware, and I can give it 500 millis. And the behavior is the same, but now I can apply middleware anywhere. I can apply this actually in the end also over here, and it'll work exactly in the same way. But now it'll apply to every URL. If you don't want to do that, if I only want to apply this timeout over here, I can apply it over here. And let's see if /slow works. Okay, so because let's put a 10 milliseconds timeout. And let's see. There you go. So request timed out. So you can use these middlewares, and there are a lot of interesting middlewares that we have. One of them is the debug. Now, debug middleware is straightforward. It'll just start logging all the requests, and it's a must-have in any HTTP library. And now when I make a request, there you go. On the left, at the bottom, you'll see something. You hit any URL, it's going to show you. Again, if you hit empty, it's not going to render. So because empty represents that there is no output available. Now that's a problem, especially with middlewares. So what you can do is you can say with empty. Now you can set this is a flag that is set, works almost in the same way as interruption does in ZIO, and has the same semantics in terms of usage. So you can say with empty, then without empty, then with empty. All these will cancel out. This is what the internal engine will care about. And if you hit this now, you'll get the 404 status code. The middlewares you can also create. Now, if I want to create a custom middleware where I want only requests below a certain size are allowed, and if the size goes beyond a certain limit, I want to throw an exception. I can do that. I can create a val, or let's say a def max content length header. So now over here, what I'm doing is I'm taking an input I, and I'm saying middleware. Now when the header, and I'm giving a condition, and so when header takes in 2 arguments, so it's saying there's a condition. If the condition is true, I want to respond with this second app. If the condition is not true, then let the first app continue. So very simple API. And here I'm just getting the request. I'm saying get content length, and I'm saying if by default is false, but if it's greater than I want to return the request entity too large status code. And I can apply this. Now let's apply this over here and give it 10. So now if the request, let's give it a smaller value, 5. If the request is, the size of the request content is greater than 5, I should get an error. Let's try with the echo app. So 1, 2, 3, 4. Let's try 1, 2, 3, 4. Make a request. 1, 2, 3, 4 works. Let's try 5. 5 works. 6. Here you go. And you get request entity too large. And you can create any kind of middlewares over here. Yeah, I think that's pretty much it from my end. We have a lot of t-shirts and caps if anybody wants at the booth. And yep. Cool.